discussing about the phase and the phase difference. It is an important lecture. When we talk of periodic motions, phase is a physical quantity that tells us about the whereabouts of a particle, that is its position and the direction of motion with respect to the mean position. In the previous lecture, we discussed about periodic functions and we learned that the periodic function can be expressed in the form of sine and cosine function. The sine and the cosine functions repeat themselves after a time period of t seconds, that is the time for one full cycle, or an angle of 360 degrees or 2 pi radians. Now, getting to the phase, when we represent a periodic motion in terms of the periodic functions of sine and cosine, they have got an argument. Argument is the terms after the sine and the cosine, the full terms after the sine and the cosine, that is called as argument. That argument of the periodic function is called as the phase. If y is equal to a sine of omega t plus phi 0, this term is the argument of sine function, or if y is equal to a cos of omega t plus phi 0, this term is called as the argument of the cosine function. Both the argument of the sine and the cosine function, as the sine and the cosine function are used to represent the periodic functions, those arguments are called as the phases. When we take this sine function, the argument omega t plus phi 0, is the phase. If we take the cosine function, omega t plus phi 0 is again the phase. Now, this omega t can be taken as 2 pi divided by t plus phi 0. This quantity is the argument and this is the phase. If likewise, we will take it as 2 pi by t into t plus phi 0. This is again the same argument and this is called as the phase. Now, this phi 0 is called as the initial phase. Initial phase. What is the initial phase? The initial phase corresponds to the phase of oscillating or the vibrating body at t is equal to 0. We can say when t is equal to 0, so omega t becomes 0. When t is equal to 0, omega t becomes 0. So we are left with the argument phi 0, and this phi 0 is called as the initial phase or the epoch. Talking of the phase difference tells us about the lack of harmony between two oscillating or two vibrating particles. The phase difference tells us if two bodies are in oscillatory or vibratory motion, which body leads, which body lags, or if the phase difference between them is 0 or 90 or 180 degree or 45 or any angle between 0 and 2 pi. Let us take an example A. We will take two vibrating bodies. Both are starting their motion from the mean position. So, the periodic function used to express this kind of curve will be sine. Let the second body be starting the motion from the same mean position in the same direction. That is, if we got two simple pendulums, one is simple pendulum, it starts its motion from the mean position in this direction. Another simple pendulum starts its oscillatory motion from the mean position in the same direction. When we express these two waveforms in form of periodic functions, we can say that y1 is equal to a sine of omega t and y2 is equal to b sine of omega t. Here the phase is omega t, What is the phase difference? Phase difference is equal to 0. What does it tell us? It tells us that the two vibrating or the oscillating pendulums start their oscillations from the mean position and at the same time they will reach the extreme position at the same time, and at every position during the course of their oscillations, their position and the direction of the motion will be same. That is the physical significance of phase difference equal to 0. Talking of phase difference of pi, let us see it graphically. Graphically, it can be seen in this way. This is y1, this is y2. y1 is equal to a sine of omega t plus pi. y2 is equal to b sine of omega t. So here the phase difference, as is evident, omega t plus pi minus omega t and omega t goes, and we get a phase difference of pi. So between these two vibrating or the oscillating bodies, we have got a phase difference of pi degrees or 180 degrees. What is its physical significance? If we take the case of simple pendulums vibrating, if we take pendulum number 1, pendulum number 1 is it has completed half cycle and its direction of motion is towards the left. When it has completed one half cycle and it has gone from the mean to extreme position in this direction, it has come back. Now it will be going in the left direction, and at that time the pendulum B, which has got a displacement equation of y2 is equal to b sine omega t, is starting its journey from the mean position in right direction. This is the physical significance of phase difference of 180 degrees. Or it can be said that when the particle A or the pendulum A has completed half cycle, after the completion of half cycle, the pendulum B starts its motion. So we have got a phase difference of 180 degrees. Talking of the phase difference of pi by 2, taking the phase difference of pi by 2, that is the phase difference between two vibrating particles is pi by 2. It can be graphically shown as this. This is the body number 1, this is the oscillating body number 2. It has already completed 1/4 of a cycle when this body starts from the mean position. So we have got a phase difference of pi by 2. We can say that if the displacement equation of first body is y1, that is equal to a sine of omega t plus pi divided by 2, and y2 is equal to b sine of omega t. So clearly here the phase difference between the two particles is pi divided by 2. Its physical significance is that the particle 1 has started from the mean position, and when it has gone to the extreme position, when it comes from the first extreme position towards its mean position, the particle starts its journey from the mean position. So the phase difference between these two oscillating or these two vibrating particles is equal to 90 degrees or pi by 2 radians. Now let us talk about the phase lead and the phase lag. The phase lead can be understood in a way that if one particle has already started the motion, and then after completing one cycle, half cycle, quarter cycle, or any angle between 0 to 2 pi degrees, the second particle starts oscillating or vibrating. So the first particle leads the second particle, or the second particle lags behind the first particle. That is the phase lead and the phase lag. We can see at the 4 equations. In equation number 1, y1 is equal to a sine of omega t plus pi, y2 is equal to b sine omega t. That means when the particle number 1 has already completed a half cycle and then the particle 2 starts vibrating from its mean position, that means we can say that the particle number 1 leads the second particle by a phase angle of pi degrees. Or this can be expressed if y1 is expressed as a sine of omega t, so then y2 is equal to b sine of omega t minus pi. That means the particle second lags behind the first particle by a phase angle of pi. When we talk of first particle, it leads the second particle by a phase angle of pi. When we talk of the second particle first, the second particle lags behind the first particle by a phase angle of pi. Similarly here, when y1 is equal to a sine omega t plus pi by 3 is equal to 60 degrees, y2 is equal to b sine omega t, it tells us the information that the particle number 1 leads the second particle by a phase angle of pi by 3. It can be written also as y1 is equal to a sine omega t, y2 is equal to b sine omega t minus pi by 3. That means this particle second lags behind the particle 1 by a phase angle of pi by 3. This is all about the phase difference, phase lead and the phase lag. Hope you understood. If it is difficult to understand, write me in the comments. I will clear the doubts. Thank you.